So here is the some analysis of the CFST Arch Bridge design using MIDAS. Um, in the design of the CFST, as I said, whether it is a 20-meter span or 200-meter span, the processes are the same. The arches are, the buckling or geometric failure of the structure is the main key. So we did the analysis using the ANSYS software to do the buckling analysis. And once the structure is shift, the size of steel tube, and we do the iterative analysis, then we do the normal kind of static analysis, for example, the bending moment and shear forces and axial forces, and all these things were computed and ensure that it meets the Australian standard. It is, and here are some other parameters. So from all these analysis, we came up with the size of the tube, thickness of the tube, and things like that. So here is the the steel around 200 millimeter diameter steel is used for the span of around 22 meter span, and we could complete that on the factory, in the fabrication plant, in the workshop. Then it is transported to the site. So here are some photos of the site. We make the very economic footing as well with just 4 pier, and then because it's mostly in the compression. So as long as the material is it's mostly in compression, and we did the actual calculation, and the stresses is not high. So why would make a very massive structure? So we did this sort of footing here, and the arch structure is moved on site in the truck, and we put in the position using the two cranes, and install our first CFST Arch Bridge in Australia. So here is the first CFST Arch Bridge that we have built. After completion of that bridge, we are also working on this about 42-meter single-span bridges. The design is completed, and in Griffith now, I think they are working around installation of this bridge area. I mean, these aspects of they are working on. And also in Victoria, we are also looking into to install the very similar sort of design in one of our river there. Also, we have been doing some sort of feasibility study of a 74-meter single-span CFST Arch Bridge. This is the detailed connection and all the design. Basically, the piers there and the hangers. This just like that. Very normal. So some technical elements that I would like to talk about here is one key things is making sure that when you are doing appraisal of the whatever projects, whether it is a arch bridge or suspension bridge or cable steel bridges or any other modular type of structures, always look into the longevity aspects. It is not fair for arch bridges because they may cost a bit higher, but actually they last longer. The maintenance cost is low. So you have to consider these aspects. So if you analyze that, you will most of the time you'll come with that arches are better. And among the arches, there are different types of steel arches there are concrete arches, reinforced concrete arches, stone arches, and many other type of arches. But you will come up with the CFS is the best solution among all the arches. So once you decide art is an option, then there are a few things you have to consider. Is now, as I said, this small scale project, but the design element is exactly the same. When you have a good uh, geometric nonlinearity analysis, and that is the only way to count it, because there is not many formulas there available to count, whether that structure will be fail in the buckling or geometric nonlinearity is a problem. Because as I said, the structurally, the from the static analysis wise, it won't it's not always a problem. The main problem is always the material, not the before material failure, it is the buckling failure. um, Also, it is very important to know that when you are pumping the concrete, you have to pump the concrete from both sides at the same time. So again, um, uh, you know it has to be balanced way. Maybe it's for a small structure, if you the steel tube is very not thick, very thick steel, and they're fine. But if you want to optimize uh, the use of the steel and material, then you have to apply the very good construction technique as well. It's always important that concrete has to be pumped from the springing, that is the from the support area to the crown, and there should be a air hole, air release hole has to be put into place. If the structure is, let's say, 100-meter single span, generally it is quite easy um, to put the half arches, putting on site like a half arches is like a 50-50, and you make it the two four pieces modular area kind of thing, and bring on the site, you connect it using the two cranes, and put it in position. You can do that very conveniently, and then pump the concrete later on. One important thing is that when you are designing this CFST structure, you have to consider the construction element as well. Because let's say first 24 hours, as soon as you pump the concrete, the steel is taking all the loads, because the concrete is still not taking, not hardened enough. It doesn't have a strength. So in your structural analysis, you should not use as a composite, but you have to use the steel as a taking all the loads. But when in the service stage, when the structure and that is different, so you have to have that analysis. When you are lifting the arches, you have to make sure that there is no local buckling in the member and brushes and things like that. So they all has to be considered. As I said, there is a good codes in China for that one, but if you apply a simple general mechanics, then it should work as well. So here is the conclusion. I will use the diagram or photographs to conclude here. These are the two bridges of the similar span. Which one did you choose? The question is for a designer, construction people, or the client, like a council, state government, and a local government or state government. The thing is that you have to consider is that in the cable state or suspension type of bridges, all the loads are taken by those cables. Think about the connection point, the cables coming there and holding on the deck. Those continuous movement, rattling of the steel, and then how much fatigue problems there. And we're talking about the life of 20 years or 50 years. And think of the problem, how many times you change the cables, and then how strong the material has to be. But in terms of the CFST, you just keep on good painting of that, then all the loads are taken in compression, and they will last forever as long as you keep on maintaining that thing. So that's why it's very important that you consider this aspect before deciding which type of braces. Um, Thank you, and I would also like to acknowledge, two directors. One is from Griffith City Council, Director Phil King, and the director from the Horsham City Council, John Martin. Because when you started this new idea, many a time people would say, you know, why would I take risk? And there is so unknown. So many construction contractor people don't know how, designing people don't know it. There is not even a code. But these people has given me the kind of, okay, Krishna, let's go, let's try it. I think that is fantastic. So I suggest you all try to challenge yourself and build something interesting and some unique. Thank you very much.